This is section 4.3, and now we're going to learn about ellipses. So there are a few things you're going to want to write down in your notes for vocabulary. And first of all, you want to draw a picture of this ellipse. There are two vertices or vertex on the left, a vertex on the right of an ellipse. And then there's foci or focus points here on the x-axis on this one. If the ellipse were in this shape, the foci would be on the y-axis. Okay, so this is the major axis because it's the longer one. This is the minor axis because it's the shorter one. So you can draw an ellipse using a piece of string and two pens. And basically, I want to show you how to go about doing this by playing this video.
The ellipse 4, the pin and string method. I have two drawing pins pressed into the sheet and a string attached to them. To get the pins to grip, I have placed a piece of timber between the sheet of paper and the 10-square drawing board. The pins are located at the focal points of the ellipse. Start at one end of the major axis. With the string taut and the pencil in contact with the paper, draw the elliptical curve. This is a very smooth way of drawing an ellipse, but not suitable for an examination situation. The string is the length of the major axis. I move the pins in now about 10 millimeters. Now the string comes out fuller, so the ellipse is going to be wider. Same length but wider. Now that's one half of it, and the top half, and that's another ellipse done. The string is the full length of the major axis.
Notice that the two vertices on this for both ellipses are at the same place, even though the foci have changed places.
And folds back. But if we took that small piece there and put it in from the pin out to the end, the string would reach from one end of the major axis to the other. So the string is the length of the major axis. Now this is the string. When it's stretched out, it's exactly the length of the major axis. When I bring it up to the top here, this is half of the major axis, and this is half of the major axis. Now I'm going to move the pins into the next position. Now the pins have been moved into the next position. This is the third ellipse now. And again,
Let's look at now how we write the equation of an ellipse. Here's the two ellipses when we have the major axis is horizontal and it's this shape here. Then it will be x squared over a squared, and a is the distance from the center to the edge. Y over b squared, and y is the distance over the center to the top, equals 1. And this particular one is centered on 0, 0 because there is nothing being added to the x or the y. Now, if there is a shift in the ellipse, this would now work a lot like our circles do, and it would be x squared minus h, I'm sorry, not a squared there, x minus h squared over a squared plus y minus k squared over b squared equals 1. So you would have that kind of a shift in this. So make sure you've written down both of these equations. Notice that if the egg shape is like vertical, the b and the a switch places. The x is over the shorter one, so it would be b, and then y squared would be over a. Note that because the sum of the distances from the point of the ellipse is to the two foci are constant, it's noted you can find this distance using Pythagorean theorem. So except in this situation, instead of a squared plus b squared equals c squared, it's going to be c squared equals a squared minus b squared. So this is the sum of all the distances to the foci. So if you look at this, we want to find the standard form of the equation of this ellipse, which is shown. And they've given us the two focus points. And so we know by looking at this, the major axis, this is going to be at 3, 0, and at negative 3, 0. And from here to here, we can't quite see the distance because it's a little bit bigger than 2. So we know that the center is on 0, 0, so we don't need to subtract anything from x and y. It's going to be just x squared on the top over a squared, which is the longer maximum major axis. Y squared over b squared equals 1. And we need to be able to find the length of the major axis, which I just showed you on the last picture. We know that it's 3 here. So when we go to write this, we know that A is 3, and we know that the distance from the center to either focus is 2. So in order to find B, the height of this, we're going to use this equation to here to here is 3. From here to here, we're not sure. And we also know that from here to here is 2. So let me draw this a little bit more clear. 2 from the focus to the center, and then from the center all the way to the end is 3. Okay, so this is going to be written like this. A is 3 squared, C is 2 squared, and then we take the square root of that. We have 5. Now we know that B is 5. So if we go rewrite this, this is A, this is B, standard form.